heat engine. So the heat, chemical energy of the fuel converted into the heat is converted into work in the engine, heat engines. There are major classification IC engines and EC engines. So internal combustion engine and the external combustion engine. In broad classification of IC engine, say I am classified based on this maximum capacity. Engine, the name of the engine is a gasoline or petrol engine. The reciprocating type, the maximum size is 4,000 kilowatt. Right? So this, what is the purpose of this IC engine? Maybe road vehicles, small and industrial purpose, and small marine propulsion of ships, right? And small aircraft and industrial electrical ships and small aircrafts. Like if you are using the gas, the same capacity of the engine used for industrial purpose and electrical power generation. Diesel engine, CI engine, same reciprocating type, the capacity, the maximum size, 40,000 kilowatt. They are used for road vehicles, industrial purpose, locomotives, marine propulsion. And the Wankel engines, this is the one of the rotary type engine, the capacity is maximum 400 kilowatt. It is also used for road vehicles and the small aircraft. They are using the engines. Jet engine, rocket engines. So you go through this, and I don't want to take much of this classification of engines. Well, the external combustion engine, the steam engine, the capacity is 4,000, which is used for locomotive and ships. Right. The steam turbine is a rotary type. The capacity is the 5 lakhs kilowatt, right? Mainly used in the electrical power generation and the large marine ships. Okay. So what is the advantage of these IC engines? Overall efficiency almost is 35%. That's why we go for the IC engine. Maximum possible efficiency is 35%. Remaining 65% as a waste, heat, right? It's dissipated to the environment or absorbing some heat. And also the mechanical simplicity, there is no heat exchangers. Suppose in case of external combustion engine, you need the heat exchanging device. But in case of IC engine, the combustion takes place inside of the working cylinder, so there is no need of special heat exchangers. Internal combustion engine, because how the combustion takes place inside of the working cylinder. That's why it's called internal combustion engine. The external combustion is outside. The combustion takes place outside of the working cylinder. So the steam turbine, locomotives, the steam generated outside of the engine. Then the steam drives the piston. Okay, but there is the heat exchange is required. But in case of IC engine, no need of heat exchanger. So mechanical simplicity. And weight, right, compared to the power ratio, is very less, right? So that automatically the cost decreases. So it occupies very less space, right? Compared to less space. There are some disadvantages also there. Because of there are many components in SI engine, IC engine. There are many components. There are many moving components. Very important problem in SI IC engine. So that vibration problem and a low starting torque and a limited number of fuels you can use, like petrol, diesel, some alcohol fuels. Right? That is the drawback of IC engines. Already you know this, the compression ratio, the maximum cylinder volume to minimum cylinder volume, it is the total volume to clearance volume. That is the compression ratio. For SI engine it is 8 to 12. 12 to 24. Right? In SIC, this is what is the TDC, top dead center, bottom dead center. Right? The piston moves in the topmost position. There is the position top dead center. So above the top dead center, there is a small volume is there. Right? That is the clearance volume or combustion chamber. When the piston moves in the downward position, right, downward stroke, bottom of the cylinder, the extreme position of the piston, when the piston moves in the bottom of the downward direction, that is the bottom dead center. In the bottom dead center to top dead center, that is called the stroke line. And this is the important components of IC engine. So the IC engine, we split into three major parts. One is the cylinder head and the cylinder block and the crankcase. Right? The cylinder head and the cylinder block connected with the use of bolts and nut. Right? So the cylinder head accommodates the cylinder, that is the valves, the inlet valves and the exhaust valves, and the ignition system. Like in case of SA engine, is the spark plug. Right? These are accommodated the cylinder head. In the cylinder block, there is a cylinder. Then the piston reciprocates inside the cylinder. Right? The cylinder connects the crankshaft. The piston connects the crankshaft by means of the connecting rod. The bottom of the system, bottom of the engine, there is a crankcase. Right? The crankcase coupled with the cylinder block. So this usually stores the lubricating oil. Okay. I will detail explain you. See, this is the potential classification, combustion process, Otto cycle, diesel cycle, fuel, gasoline, diesel, LPG, CNG, alcohol, and hydrogen. And how to, in the mixer, right, mixer generation system, the type of mixer generation system, external mixer generation and the internal mixer generation. The external mixer generation, it might be by means of the carburetor, right, the fuel and air mixed thoroughly outside of the engine. So the mixer is allowed to enter the cylinder during the suction stroke. So the internal mixer may be in the CA engine, right? They are alone entering into the system. Right? After the end of the compression, these are injector inject the diesel. Then the mixing takes place. That is the mixer generation system. And the quality of mixer generation, homogeneous and non-homogeneous. So homogeneous in the SA engine, non-homogeneous in the CA engine. And method of mixer generation, right? Corporation. SA engine, direct injection, gasoline direct injection, indirect injection, intake manifold injection, drop-in cycle, post-stroke. And a control system, gas exchange control system by valve and port timing, overhead valve and right, side actuated valve. Open chamber and divided chamber. And the charging system, natural aspiration, supercharging, exhaust, supercharging, crankcase compression, and arrangement of the cylinder, right, cooling system, ignition system. We'll discuss one by one slowly. Okay. So next, what is a pre-mixed and a non-pre-mixed charge engines? Right? I already told you the SA engine, the air and fuel, right, air-fuel mixture prepared in the carburetor outside of the engine supplies the correct amount of air-fuel mixture to the engine during the suction stroke. So before entering to the cylinder, the air-fuel mixture, right, the charge already thoroughly mixed in the carburetor. Even during the suction, then during the compression, right, the pre-mixed charge already available before igniting the air-fuel mixture in the SA engine. But in case of the CA engine, air alone entering into the system, right, at the end of the compression, the air is compressed. At the end of the compression, the injector injects the diesel. After injecting, only this mixing takes place. That is the heterogeneous mixture. See, this is the valve, how the valves actuate, right? Push rod. Right? See here, there is the crankshaft, and there is a camshaft parallelly mounted inside the engine. To the end of the crankshaft, there is the crankshaft sprocket. It contains a very small gear. There is another one larger gear, almost twice the diameter of this crankshaft sprocket. It is mounted on the end of the camshaft. Okay. So these two sprockets connected by means of the chain, or directly maybe we can fix the, instead of the sprocket, we can fix the gears. Then the two gears directly connected. Or otherwise we can connect by means of belt also to transfer the motion from the crankshaft to camshaft. What is the purpose of this camshaft? So the camshaft contains the many cam. So cam is nothing but it's not a circular, right? It is the some ellipse shape, like an egg shape, right? So each cylinder having the two cams, Then what is the purpose of this cam? See, even we can rotate the crankshaft automatically. We can rotate the crankshaft. Then automatically the power transmitted to the camshaft through this chain. Then this camshaft also is turned. So due to this rotational motion, the cam, right, it also rotates. Cam changes always, right? So that due to the profile of the cam, when the larger portion hits the push rod, then the push rod moves up and down based on the profile of the cam. Then the other end of the push rod, there is one rocker arm facilities are there. So this rocker arm push the walls up and down. Right, the rocker arm push the walls in downward direction because of the spring, compression spring incorporated in this wall. So due to this spring action, again the wall is seated to the original position. And this, the wall gets actuated. The walls, right, opens the inlet port and closes the inlet port. Similarly, opens the exhaust port and then closes the exhaust port. At the right time, this valve will open. We can fix it. We can fix what time this valve will open. Then the air fuel mixture entering into the system. This is the overhead system, right? The camshaft and the crankshaft. The camshaft, right? You could put the base in the top of the piston, similar. Okay, this is the configuration. See, the cylinder are 2, 3, 4, 6 cylinder, 4 cylinder, 6, 8, 12. So the 4 cylinder up to 2.5 liters capacity, 6 cylinders 2.5 to 4.5 liters capacity. So more than 6 cylinders will be very big, long, right? Very long. And the 12 cylinders will be large ships. We can use the 12 cylinders. And we take engines. The angle of the inline engines are 60 degrees. Maybe the 8 cylinder or more has excellent balance. And I oppose the cylinder system also there. You can go directly. Yeah, this is some of the representation, the inline, new cylinder, V type, X type, right? The radial type, H type, opposite cylinder, opposite piston. Okay. And this is one of the largest engine built in Japan. We're using the ship container ships, right? Container ships. We kept the specification of this engine, that is 14 cylinder, right around 2,300 tons. The length 89 feet, you assume how much length it is. The height 44 feet, the maximum power, like you see, how much horsepower and RPM. So even this RPM, see, they have this RPM, 1 or 2 RPM. So the size of the engine is bigger, then automatically the revolution per minute RPM, the speed gets decreases. The smaller size, then you can increase the speed of the engine. Okay. Then in operating cycle, so we have the 4-stroke engine and the 4-stroke engine. 4-stroke spark ignition engine. Already you know very well about the 4-stroke SI engine. So 4-stroke, not the 4-stroke, actually the 4 events: suction, compression, power, and exhaust. Right? The 4 events completed by 2 revolutions of the crankshaft. When the piston moves from top dead center to bottom dead center, so that time this inlet valve gets open. So the air fuel mixture, remember air fuel mixture entering the system, right, during the suction stroke. Again the piston moves from BDC to TDC to top dead center, then the mixture gets compressed, air fuel mixture gets compressed. At the end of the compression, the ignition, right, the spark plug. The spark plug ignites the air fuel mixture at the end of the compression, then immediately the combustion takes place. We will discuss later how the combustion happens. Right? So due to combustion, the pressure and temperature increases. Again, the pressure pushes the piston in a downward direction. Okay, due to inertia, again piston moves from bottom dead center to top dead center. That time the exhaust valve gets opened. Right. So remaining these two, in between the compression stroke and power stroke, the valves get closed. So at what time this inlet valve open, what time it closed, similarly what time the exhaust valve open, closing, everything determined by the valve opening of the camshaft, right? So that you can fix the number of gears, right? Number of gears fitted in this camshaft as well as the crankshaft. Okay, this is the SI engine. What is the SI engine? The spark ignition engine. Right? Why we go for need of the spark ignition? Because of we are using petrol as a fuel. Right? The ignition temperature is very high. Right? That's why we use of the additional device spark plug. With help of the spark plug, we can ignite but no need of the spark plug in case of the CA engine. Instead of the SI engine, there is an injector. Because of this ignition temperature of diesel is less compared to petrol. So that we can achieve the ignition temperature based on the compression alone. That's why it is called the compression ignition. We can see. Okay. The section, then compression, at the end of the compression, the spark plug ignite the fuel and power stroke, then the exhaust stroke, the unburned gases are in the top of the cylinder, it exhausts the exhaust. And after cycle already studied, maybe the last first session you can study the after cycle. You can skip this. So this is the wall timing diagram for the low speed and high speed engine. See in the wall timing diagram, the low speed, what is the time available or what time this intake opens, right? Around C15 degree from before the dead center. With the high speed engine, what is the intake valve opens? Intake valve opens around 10 degree before PDC. Okay. See, first the intake valve opens here also 10 degree before PDC. Then the intake valve closed after 10 degree BDC. Right. But here in case of high speed engine, see what is the intake duration after 60 degree. After 60 degree before after BDC. Right. Almost it takes more angle of suction. What is the reason? Because due to high speed, there is no time to suck the fuel, suck the fuel mixture. That's why you can increase the duration of the. Then again compression, at the end of the compression, say 15 degree before PDC, this got ignited. And see, just you compare the high speed, what is spark ignited 30 degree before PDC. Because of the high speed, there is shortage of time to suction the fuel. That's why you can increase the angle. Right? Then the power stroke, the exhaust opens before BDC, 25 degree in case of a low speed. See here the 55 degree, see the exhaust valve open. So this exhaust, right? The exhaust to the atmosphere to this exhaust. Oh, right? Okay. Yeah, see, this is the same typical angle, right? Low speed and high speed engine. Inlet valve open 10 degree before PDC. Both cases opens 10 degree before PDC. But the inlet valve closes 10 degree before PDC, but in 60 degree before PDC because of due to time available. The exhaust valve. Okay, post-stroke CA engine operation. So already you know what is suction, compression, power and exhaust. So here what is the difference? Already I told you the injector. Instead of a spark plug, we have the injector, inject the diesel. What is the working medium? In CA engine, air alone entering into the system. There is no mixing of air and the fuel outside of the engine. So air alone entering the system, the air is compressed. At the end of the compression, almost the end of the compression, is the ignition temperature of the diesel. We have inject the diesel at the right moment. So once the fuel is injected, after injection only the fuel, right, mixing the air, then it attains the combustible range. After that the combustion takes place. So that there is the various sites. The ignition occurs various places in the combustion chamber. But in case of the SI engine, right, the combustion, after combustion, right, the flame, the constant flame, the flame propagates, the flame develops, the flame propagates across the combustion chamber. Okay, there is a definite flame, But in case of CA engine, there is no definite plane because of the various sides. This attains the air fuel mixture, attains the ignition temperature. So there the combustion starts. Right? That's why the sudden pressure increases in the cylinder. So that we can go for the bulky engine for a CA engine. That is the difference of a SI engine and a CA engine. Well, this is the typical load timing diagram for a four-stroke engine. The CA engine. See, this is the 30 degree before PDC, the inlet opens. But in case of a SI engine, it is the 10 degree before PDC. So here, because of ultimately more amount of fuel. That's why we can the more amount of air. So this injection starts at 15 degree before PDC. So this is already suction and the compression. At the end of the compression, the injector inject the diesel. Right. So the injection starts 15 degree before PDC. Then the injection stops after PDC around the 10 degree maybe 10 degree. Right. So that the fuel is right. We keep on supplying to this engine, keep on injecting the cylinder. Right. That is the four-stroke SI and CA engine. I hope you understand. Two-stroke engine. So in four-stroke engine, they are already very well with the for even suction, compression, power, and exhaust. It is completed by two revolutions of the crankshaft. Right. But in case of a two-stroke engine, again the four events are there: suction, compression, power, and exhaust. So these four events completed by one revolution of the crankshaft. That's why here there is no suction stroke, compression stroke, power stroke, exhaust stroke. So here only downward stroke or upward stroke, or first stroke or second stroke. See, just you look this diagram. See, the piston initially moves from top dead center to bottom dead center. So here there is no inlet valve, exhaust valve, inlet like that. So there is no valves in case of a two-stroke engine. Only there is a port, inlet port and exhaust port, and one more port is a transfer port, right? So when the piston moves from top dead center to bottom dead center, the piston covers the port, inlet port and exhaust port and transfer port. So there is no need of valves to close the ports. Okay? So we can eliminate the valve actuating mechanisms, and cost-wise it is decreases. Because there is no need of valve actuating mechanism, valve actuating device. So when the piston moves from top dead center to bottom dead center, that is a downward stroke, right? The downward stroke. Slowly the piston uncovers the transfer port. See, even the piston, it is in the top position, top dead center. See, the inlet port gets open, right? So the inlet port, because of the opening of the inlet port, the air fuel mixture entering to the bottom of the piston. But in case of a four-stroke engine, the suction takes place in the top of the piston, but here it occurs in the bottom of the piston when the piston is in the top position. When the piston moves from top to bottom, slowly this uncovers the transfer port, uncovers the first transfer port. Okay, so if the piston compresses the air fuel mixture, which is available in the bottom of the piston, it is available in the crankcase. That's why it is called the crankcase compression. So due to this compression, right? Due to this compression of this suction product, right? There is the connection between the crankcase and this cylinder, right? That is the transfer port. So these compressed products, when the piston moves from top dead center to bottom dead center, these compressed products, right? It reaches the top of the piston through this transfer port. When the piston moves from top dead center to bottom dead center, that is the downward stroke, right? Okay, so this system, this is the suction and expansion takes place when the piston moves in a downward direction. Suction happening in the bottom of the piston, and also the expansion, right? Already the previous stroke, the air fuel mixture occupied there, that is the combustion. Due to the compression, this piston moves in a downward direction. That is the expansion. So, in one movement, the two events finished, suction and expansion. Okay. Then the piston moves from bottom dead to top dead center. Then what's happened? The compression, right? The compression of the two. So the inlet port is closed, right? So compression takes place. Compression. At the end of the compression, the exhaust. So one downward stroke, the suction and expansion, and other stroke, exhaust and the place. So during this time, so these are fresh charge flows from the crankcase to top of the piston. The fresh charge gas force the unnecessarily outside the side. Right? This is let of the cylinder with the help of the and this engine or all the port and diagram. See, that is the one stroke and the upward stroke. Expansion from the piston moves from top dead center to bottom dead center. First it's opens the exhaust. The piston moves from top dead center to bottom dead center. First the exhaust port, right? Exhaust port. Then it opens the inlet port. Now the piston moves in the top dead center. Then see the intake port, right? How much distance is opening around 43 plus 43 degree, right? 43 degree before TDC and closes the open duration. It never generates the maximum. That's why it opens 20 degree before TDC. Okay, I hope I already explained post-stroke engines. The post-stroke engine, the emissions to emissions per capture, the more volumetric efficiency and high thermal efficiency. And two-stroke engines, the engine is lighter. The construction is simple. Less efficient, reduced volumetric efficiency. Okay. And the SI engine, we just look at this, what is the compression ratio, 6 to 12. Right. In CI engine, the compression ratio is 12 to 22 because of this, there is only a ignition medium. Right. So, see, SI engine mixture preparation, how to prepare the air fuel mixture. Prepare in the carburetor, right? So, this what is the purpose of the carburetor? It mix the air fuel mixture at correct proportion, right? Because the engine operated at different loads and different speed. For the particular load and particular speed, the correct amount of air fuel mixture supplied to the engine. Right? There are three different mixtures. Chemically correct mixture, a stretch mixture, and the lean mixture. What is the chemically correct or stoichiometric mixture? So enough amount of air neatly bound the fuel. That is the chemically correct mixture. Just enough air for complete combustion of the fuel. So how much air required for bound 1 kg of octane? It is 15.2 kg of fuel. Right? That's why the stoichiometric air fuel ratio is 15.2:1. That means 15.2 kg of air is required to burn 1 kg of petrol. Okay. So rich mixture right, which contains less air than the stoichiometric air fuel ratio. It is a 12:1 or 10:1. That is the rich mixture. So lean mixture is greater than the stoichiometric ratio. Means 17:1, 20:1 is the lean mixture. So there are different mixture required for the different load conditions. Right? I can tell you. See, this is the power output and the brake-specific fuel consumption versus the air fuel ratio. So what is stoichiometric air fuel ratio? Is 15:2.1. Right? 15:1. Right? See, in this condition, the brake-specific fuel consumption, right, the best economy around 16:1. But what is the power output? It is compared to not giving the maximum power, right? So when we get the maximum power, if the fuel is the rich mixture, is to 1, it gives the maximum power because of the more fuel, right? It generates the more. It gives you more heat, more combustion, then it gives more power. But in case of cruising speed, we have the very specific fuel consumption. Fuel consumption is very less. We can get the average speed. When we go for the sudden acceleration, right? That time we need more power. That time it gives the, you go for the rich mixture. Right. So these different conditions, the carburetor to supply the different air fuel mixture, the different conditions. Okay. See, in this graph you can find that 12:1 is the best power and 16:1 is the best economy. See, this is the mixture requirement for various conditions. See, already you know what is the combustible range. It is 7:1 to 20:1. That is the combustible range. Okay. Beyond this 2 weeks, right, there is no combustion. There is a failed combustion. Lean, beyond the 20:1, there is no combustion happening. So the combustible range 7:1 to 20:1. Right. Now, what is the range of idling range, cruising range, and power range? See, this is the idling condition. Idling condition. So the carburetor is located outside of the cylinder. After carburetor, there is a throttle valve. So in idling condition, runs idly, right? There is no movement. That time the throttle valve is almost closed condition. Around 90% of the throttle valve is closed, right? So that time, this already the residual gases available in the top of the piston, right? So because of the pressure difference, these residual gases flows through the by exhaust port, right? So already the throttle valve is completely closed, 90% of closed. Then we can supply the air fuel mixture. What type of air fuel mixture we are going to supply? Suppose we are supplying the lean mixture, then already the exhaust gas available here. The exhaust gas diluted the air fuel mixture, so there is no combustion happening. That's why we can supply the small quantity of fuel with the rich mixture. Then only its combustion takes place. Because of there is a dilution problem, right? Engine operates no load with nearly close to throttle. Engine requires rich air fuel mixture 7:1. Condition within the combustion chamber, an intake manifold crosses the exhaust. More quantity. Throttling, then this mixture, right? It comes to gradually decreases. So it comes to the lean mixture, right? Point A to B. Then B to C, the best economy. The fuel is gradually throttle valve. At the same time, we can run the by the lean mixture. So suddenly, phone suddenly we can increase the speed or overtaking some vehicle. Hello? Yes, sir?
Sir, voice is disturbing, sir.
Voice is for a long time or?
Disturbing breakage. Between sometimes it is breaking, like a network issue. Breakage.
Okay, now
Voice
it's
breakage
fine.
there.
Now
Now it is okay, sir.
Okay. Suppose you
Okay.
just you intimate
Okay.
me. Okay. Thank
Yeah.
you for interruption.
Thank you.
Okay. See, next we can run the vehicle for hillways. Then we need the more power. But the vehicle runs at a slower manner, slow speed. Even the slow speed, we need more power. Then we go for the rich mixture. Okay. So then, of course, the daughter very indicates. So whenever we go for the idling condition, we need the rich mixture, but the quantity is very small. Whenever we need more power, but the vehicle runs at a slow speed only for purpose in case of a hill station, right? We need the rich mixture. So the carburetor supplies the different air fuel mixture to the different conditions. That is a very tough task of the carburetor. Yeah, already explained to you. 50% open. Then there is a diminishing of the dilution problem because of we separate the almost match with this pressure conditions. The dilution problems can be eliminated in this producing the range. Then the power range is supposed to open throttle valve, right? Supplying the ratio is supposed to want to provide the best power and also prevent the overheating of the exhaust valve. Vehicle runs at a cruising speed, then the temperature higher in the combustion chamber. So due to this higher temperature, the valve gets overheated, That's why we supply the rich mixture, reduce the combustion temperature also, reduce the valve to provide the combustible mixture, right? Air fuel mixture with proper amount calculation before admitting the engine cylinder. The function, the carburetor does this function. So what are the factors affecting the carburation? The engine speed, vaporization characteristics of the fuel, air, and the design of the carburetor. So these are all important factors to affect the carburation. Suppose if you are increasing the engine speed, right? The engine running at 3000 RPM. Eligible for mixing the air fuel mixture within 10 milliseconds. Okay, so it's affect the mixer ratio, right? So that we need the special shape of the carburetor in order to have high quality. The velocity of the stream at the point where the fuel is injected has to be right. So how to increase the velocity by providing the friction? I show you the diagram. Precision characteristics of the fuel. Volatile hydrocarbons affect the carburation. And the temperature of the incoming air. The temperature of the incoming air, hot air, higher air temperature increases the vaporization characteristics. Then it's more volatile. Then it takes place. So increase the atmospheric temperature leads to decrease the power output of the engine. When the air fuel pressure constant to reduce mass flow. Correct? To increase the atmospheric temperature, it makes the lean mixture, right? Then automatically the power gate decreases. That is one of the drawback. Yeah, this is the carburetor. So this is the see, I already told you the carburetor how to increase the velocity of the air velocity by providing the venturi section. Because of the engine runs at a higher speed, there is no time to mixing. That's why we can increase the velocity by providing the venturi section. So there is one separate float chamber. So this filled in the float chamber, the float is right, the floated on the fuel. There is a connection between the float chamber to this choke tube. There is one pipe that connects the small tube. So the level tube is a height, right? Slightly higher than the level of the petrol float chamber. Because if the level is equal or little lesser, the continuously fluid is ejecting from the nozzle. Okay, that is the purpose of this fluid. This nozzle is slightly placed above the fuel in the throat chamber. That is a right? So in the choke valve, how the choke valve is completely open, the air entering into the system, right? Then air. So here at the same time, the fuel is leaked from the nozzle. So the air fuel mixing takes place in the air. The higher velocity of the air carries the droplets of the petrol and the mixing takes place. So based on this opening of this inlet valve, the throttle valve, the right amount of air fuel mixture entering into the system. So we can control the valve, throttle valve, depends upon our requirement. Okay, I hope you understand. So effects of simple carburetor. The carburetor is suitable for particular low and speed conditions. Right? The carburetor is a high speed throttle. It will not work properly at a low speed and power. That is the drawback. Even if the carburetor, we can set the carburetor at a particular speed and load only, but it's not possible to operate at a lower speed and.
Sir, voice is not clear, sir.
Hello.
Sir, voice is not clear, sir.
Voice is.
I think network issues.
Yes, yes.
I think network issue you have, sir.
Maybe here still.
Now it is okay, sir. Now it is okay. But before 1 minute, it completely went.
Okay, sorry, sir.
No issue.
It's not. Start again with the
I think there is a net issue, sir. Please kindly come to the net. Yeah.
Right now you are getting my voice, sir?
Yes, now you're getting the voice.
Hello.
Just remove the phone.
Yeah.
Directly speak with the laptop. It is okay, I think.
No, I'm speaking with the laptop only, but I'm keeping the mobile nearer to me. Can I keep the mobile away from me?
Sir, keep outside mobile. Keep outside, sir.
Okay. Okay, now you are getting my voice, sir?
Now it is clear, sir. You can proceed.
Okay, fine. Okay, that's okay, so these are the drawbacks of the simple carburetor. Then how can we overcome these drawbacks? Then we go for the complete carburetor. We can attach some attachments. Right? Attachments we can attach.
Sir, once again, sir.
Hello.
Yes, sir. Just now only I will hear your voice, sir.
No, sir, there is no voice. I think fully
Very poor network.
network is very poor.
You just take him to professor. They don't see the
Some net sort out soon.
ஓகே சார், நெட்டு சரியா இதாகலன்னு நினைக்கிறேன் சாருக்கு. வெயிட் பண்ணுவோம்.
Hello? Hello? Vivek, no? Vivek, no? Hello? Can I audible?
Yes, sir, but the background noises are there, sir. The voice is audible.
Actually, my net connection maybe.
Yes, sir.
Okay. I will continue again.
Yes, sir. Yes, sir. No problem.
Yes, continue, sir.
Yeah. Okay, I will continue. Okay. Yeah, its screen is visible now.
Yes, sir, it is visible.
Hello.
Yes, sir, visible, sir.
Okay. So, sir, there are some limitations of a complete carburetor also. See, in case of a single cylinder, there is no issue. The carburetor located very near to the particular cylinder, the carburetor supplies that particular amount of air fuel mixture. But in case of multi-cylinder, just to look the left-hand diagram, there are 4 cylinders, 1, 2, 3, 4. The carburetor located at the extreme, nearer to the 4th cylinder. Suppose the carburetor supplies the particular amount of air fuel mixture, right? The fuel travels, air fuel mixture travels from the carburetor to 4th cylinder. Then it is travels to 1. So during this distance, during this time, some of the air fuel droplets, right, are deposited on the walls of the inlet manifold. That's why there is some different air fuel mixture, right, entering into the cylinder. That is the drawback in case of multi-cylinder. At the same time, the volumetric efficiency is very less because there is no restriction, right, in the carburetor. There is the choke and there is maybe the venturi and the throttle valve. Because of this, the volume flow rate of the increases. That is the drawback of this complete carburetor. Okay. So then how to provide the correct air fuel mixture? Then there is some feedback control carburetor. See, there is the engine, right? So there are various sensors mounted various locations in the engine, like a temperature sensor, pressure sensor, right? Oxygen sensor, right? And this one crank angle encoder sensors, various sensors sense the situation. What is the current position? What is the amount of? What is the type of air fuel mixture required for particular condition? Right. These sensors into the ECU control unit. Then this control unit, based on this information, is received from the various sensors. So this control unit, this signals to the actuator. That is the fuel injection system. Accordingly, the fuel is injected into the cylinder. That is called a feedback control carburetors. Yeah, same this one. Okay, I already explained the polar carburetor, mole distribution. What is the mole distribution problem? That is the, in case of the multi-cylinder engine, the correct amount of air fuel mixture supplied to all the cylinders. Some of the droplets deposited on the walls of the cylinder. Injection. Right, there are two. Then you go for the fuel injection system in case of the SA engine. So in these 3 injectors, I can show you the 3 injectors here. Right, types: throttle body injection, multi-point injection, and the gasoline direct injection. So what is a throttle body injection? See, there is one the induction manifold where the one injector is mounted on the throttle body, just above the throttle valve. So this injector inject the fuel, gasoline injected through this injector. Okay. So then the air is coming from the outside, then the air mixing takes place before the throttle valve, then the mixer is entering into the cylinder. It's similar to the carbureted system. Right? I can show you the another diagram. See this one. Throttle body injection system. So here there is, right, the 4 cylinders connected with the intake manifold. So the air is coming through the carburetor. Okay. So this injector is slightly mounted just above the throttle valve. So this air and fuel is mixing takes place. The air fuel mixture supplied to these various cylinders. Okay, it's like just like the carbureted engine. So the pressure is very low, 2 to 6 bar. Right. The cost wise low. That is the advantage. Only there is one injector, right? This one injector inject the fuel to all the cylinders. And here also there is a mixing and distribution problem of the carburetor. Okay. So the better efficient over, but comparatively the efficient of the carburetor, the improved fuel economy. So there is a limited intake manifold design. That is about that. So this is the multi-point fuel injection system. So this is air entering, right, in the intake manifold. Then based on the throttle valve, we can control the flow rate of the air. So there are different injectors. Each here how many 4 cylinders? The 4 cylinders having the injectors. One injector placed just above the cylinder. Okay. So this air coming from the inlet manifold, then the air and the fuel mixing, already the mixture available is waiting outside of the each cylinder. Whenever the suction then the mixture entering into the cylinder, right? So before injecting, the air fuel mixture ready in the outside of the cylinder. Each cylinder there will be one injector. So this is also the injection pressure is low, 2 to 6 bar is required. Synchronized with the engine induction cycle. Okay, so the first cylinder by section, right? The second cylinder. So all the cylinders readily available will be air fuel mixture. So we not wait for the particular induction, right? That is the advantage. So fuel can be discharged simultaneously to each induction coil, where it is mixed and stored until inlet valve open. So before inlet valve open, it is readily available. Okay, so here there is no fuel distribution difficulties. So better fuel economy, the high power output. Okay, this is the suppose in case of gasoline direct injection system. So this is the spark plug, inlet valve, exhaust valve. So the fuel is directly injected into the cylinder. There is no intake manifold, everything. The injector is located directly inside the combustion chamber. So the fuel is injected like a diesel engine. Okay, so that's why it needs the high pressure. Because of already the high pressure available in the combustion chamber, so it needs the high pressure, high injection pressure. Compensation for the time for the injection must be designed for high pressure and temperature. So costlier than other type. So it enables a stratified fuel charge conversion. So stratified charge a different fuel mixture, different air fuel mixture supplied at the different locations. Suppose in case of we need the rich mixture near the spark plug, it is possible in this case of gasoline direct injection system. Some of the fuel injected near the spark plug, remaining fuel is focused to the remaining area of this one. So controlling combustion emission more precisely by this way. Okay. And this is an electronic fuel injection system. There are various sensors mounted in various locations. The sensors sense then the information passed to the CPU, ECU. Then based on this information, this signals go to the actuator. Then it injects the. So what are the various sensors? See the airflow meter, ignition coil, coolant temperature sensor, throttle pushing sensor, oxygen sensor. There are various sensors. Right, the sensors connected to the ECU. Then it's the signal should be injected. Based on this signal, it injected this. But what are the various sensors? See mass airflow sensors, exhaust sensor, throttle pushing sensor, like that. This is circuit sensors. The analog signals converted to digital world. Then it gives the microprocessor the output. Right? Okay. Yeah, next we go for the injector. The injector. The injector inject the correct amount of air fuel. Amount of time of the fuel injector stays open. Injector gets open. How much time gets open? Not fuel is injected in fuel. So this pulse width, right? The pulse width is controlled by the ECU. So open conditions including very sensors inputs. Right? Already told you the injection pressure is of 5 bar. The pulse duration is 1 to 1.5 milliseconds. Okay. Right, that is the SI engine. Now we move to the diesel engine. The SI engine, the air fuel mixture already we discussed. The air fuel mixture prepared by the carburetor. But in case of diesel engine, air alone entering into the system will come at the time of compression, at the end of the compression, right, the diesel injected to the cylinder. According to pressure is around the compressor pressure is 35 to 40 bar. Around the temperature is 600 degrees Celsius maintained inside the combustion chamber at the end of the compression. So the fuel is injected through the nozzle, right, at a higher pressure than that of the air pressure. So normally it is 200 bar or 225 bar. fuel is injected. So what is the requirement of fuel injection system? The beginning as well as end of injection should take place shortly. That is the requirement. So inject the fuel at correct time in the cycle. Throughout this fuel range, the injection of fuel should occur at the correct rate and the correct quantity of fuel. Atomize the fuel to the required degree. After injection only we can atomize. That's why this how much pressure is needed. That much pressure we inject the diesel to the system to ultimately atomization takes place. Suppose we inject the diesel with very less pressure, there is no atomization. So this will be fuel throughout the combustion chamber for better mixing. Like that we can provide the shape of the piston and valve open everything. Air injection system, airless solid injection system. See this air injection system, the air is injected, right? The fuel is injected along with the air. So that it needs some multi-stage compressor, right? The multi-stage compressor attached with the cylinder engine. Then only it compress the fuel is injected along the compressed air. So the weight is increases. Right? So, but this method is a better atomization and the penetration of the fuel, right? Increasing the brake, increasing the higher brake temperature. And solid injection system, right? The fuel directly injected into the cylinder. That is a solid injection system. So it needs the pressurizing unit and the injector unit. There are different classifications: the common drive system, unit injection system, individual pump and the distributor system. See the common drive system. See this diagram. The header is available here. There is one high pressure pump. So the fuel supplied from the high pressure pump to the header, right? So this high pressure line. So the fuel is taken from the fuel header to the each injector. So the injector is located at the top of the cylinder. So each injector located at the cylinder. So the high pressure pump supply the fuel to the injector. So the injector inject the diesel to the cylinder at proper time. So this is the common drive injection system and the unit injection system. So unit injection system, there is the high pressure pump located nearer to the injector. But in case of common drive system, there is one common pump, high pressure pump, supply the fuel to the each cylinder. But in this case, there is a separate high pressure pump located in the each cylinder. That is the difference. The low pressure pump supply the fuel to the high pressure pump. The high pressure pump supply the fuel to the injector at right moment. The fuel is injected. Okay. And this is an individual pump system. So in the previous case, the injector pump is located very near to the injector, but in this case, the fuel pump is located far away from the injector. Right? Separate pumps. The pumps in cluster. The both pumps in connected to the same place. So based on the situation, we can use the different types of pumps. Okay. And a distribution system. So in distributor, there is only a distributor. Right? There is a low pressure pump. The pump supplies the fuel to the distributor. So the distributor supply the fuel to all the cylinders. Right? The high pressure fuel supply to all the cylinders. Then the fuel is injected into the cylinder. That is the distributor system. Next, the fuel injectors. Right? So there is the needle valve, compression spring. See the components of the injector nozzle. See the needle valve, the fuel supply line. Right? The fuel supply line, the high pressure fuel is going through the supply line. Then the needle valve, there is one spring and right attached to the end of the needle valve. You can adjust the force by rotating the spring. There is a handle is there, the screw is there. You can adjust the pressure, what pressure it is required. So initially this high pressure fuel entering into the fuel passage line, it lifts the needle valve. The pressure is higher than the spring pressure, compression pressure. So this way the fuel is injected into the cylinder. Right? So what pressure we can adjust? That is the injector. Nozzle. There are different holes, single hole, interval, multiple hole, nozzle. Right? Single hole, the angle 15 degree, the pressure is 18 megapascal. Suppose in case of this interval nozzle, it is 8 to 10 megapascal. Right, the multiple holes, see there are 3 holes, 2 holes, then that was 20. Then there is an auxiliary hole also there. So due to the high pressure, initially through this auxiliary hole, some amount of fuel is injected into the cylinder so that the preparatory, the combustion range already is available in the cylinder. Right? This enhance the combustion, increase the combustion. Right? That is why the auxiliary hole is there. After that, the fuel is the cylinder, right? The wheel valve will get lifted. Then the maximum quantity of fuel is goes through this main nozzle. It's a conduction nozzle. Okay. Slide. There is no issue so far. Hello. And
Sir, no, sir. We can't see.
Yes, sir. Yes, sir. It is now
We
you are
can't see.
now, sir. You are showing combination in SA engines.
Yeah, combustion SI is there.
Yeah, combustion in SA.
Okay, right. So far we discussed the injection system and what are the important components of IC engine. There are different cycle, SA, post-stroke, two-stroke engine. Right. Then we go for the combustion SA engine. How the combustion takes place inside the SA engine, like that. See, the combustible range already I told you. It is the hydrocarbon fuels. The hydrocarbon limit, ignition limit of the hydrocarbon is a 7 to 30. Air fuel ratio 7:1 to 30:1. It's a theoretical range. Getting some voice, some sound. Somebody is opening the. Please mute. Yeah, correct. Thank you. But the practical limits 9:21 is the practical limit. Right? So what is the combustion? The chemical combination of hydrocarbon react with the oxygen. Then it's liberation of heat, liberation of energy in the form of heat. So this is a combustible air fuel mixture, combustion of the fuel air mixture. This depends upon the chain reaction of the fuels. There are different conditions. So the combustion takes place because of the presence of combustible mixture. Even the mixture available, but it is not a combustible range. There is no combustion. Right? So it is within the limit. What is the limit? 9:1 to 21:1. Right? Some means we have the initiating the combustion. How we can initiate the combustion? We need this spark plug. Right? In case of SI engine. Then stabilization and propagation of flame in the combustion chamber. Once the fuel is ignited by the spark plug, then there is the flame forms immediately after certain time. Immediately flame forms. So the definite flame, right? The definite flame travels across the cylinder. It burns the unburnt charge. It eats the unburnt charge. That's why the flame propagates through the cylinder. Same time, it increases the pressure and temperature. Okay. Types of combustion. See, this shows the theoretical and actual. In theoretical, the combustion takes place the BDC to BDC. Once the piston reaches in the top dead center, immediately the heat supplied to the engine at a constant volume. The heat takes place at constant volume, right? Then suddenly the pressure increases. That is the because of heat addition. Then the piston is in top dead center. At the same time, the next stroke is the expansion stroke. Then the expansion, that the pressure is decreases. At the same time, all the fuel gets burned. Right? Then the pressure and temperature decreases. That is the actual, theoretical P theta. But in the actual case, it's not happening like that. There are 3 stages of combustion, right? Ignition, lag, the preparation of the flame, and after burning. Right? What is the ignition lag? See, I can show you this one. See at point A, around 20 degree before TDC or 80 degree before TDC. At point A, once the piston at the end of the numbers, right? Suppose it is a TDC 0, the piston is in top dead center. But before TDC, some angle. What is the angle? Around 40 degree or 80 degree. That time the spark ignite the actual mixture. Once the spark ignited, immediately there is no combustion happening because at that moment the air fuel mixture not attain the ignition combustible range. Somewhere attains the combustible range, but the entire is not attain the combustible range. So at what time it combustible at point B? At point B, the fuel is attains the combustible range, right? It's ready to heat combustion. Once it attains this range, then immediately the pressure increases. Suddenly the pressure increases to C, B to C. So A to B is the ignition lag, the time available for preparing the actual mixture to combustible range. Then B to C. Once this flame forms, so the A to B is the formation of the flame, right? The growth of the flame, right? The time taken to growth of the flame, development of the flame. Once the flame is developed, then is the flame, right, travels across the cylinder, right? So it consumes the unburned discharge. The piston, right, the cylinder, the flame moves at the end of the cylinder, right? Then it will consume the amount of fuel. That is called the propagation of the flame. So it is something, it is the, depends various factors. We will see the various factors. What are the factors affect the ignition lag? What are the factors affect the propagation of the flame? Then after burning, third stage. So after burning, almost the piston reaches the top dead center. Correct? Even the after TDC, some angle 5 or 10 degrees Celsius. Sorry, 10 degree after TDC. Right? Then there is no fuel available there. And also the expansion starts. Then the pressure decreases and temperature also slowly decreases. So this is the 3 stages of combustion we say. And already I told the ignition lag, what are the factors affect the ignition lag? See, the growth and development of the semi-propagated nucleus flame around the 10 to 20 degree in terms of seconds, 0.001 is the ignition lag time. So it depends on the nature of the fuel, mixture ratio, initial temperature and pressure, and the relationship between the temperature and the acceleration of burning, and the compression ratio, electrode gap proportion of the exhaust gases. Okay. See, this is the mixer strength, mixer strength. It depends upon the ignition, depends upon this ignition lag. So mixer ratio is richer than the cyclic ratio for small ignition lag. Okay, see this diagram, mixer strength 120, 1.2. So it is a little richer than the cyclometric ratio. The ignition lag time is around 0.5 milliseconds. Okay. So suppose in case of 2 rich, again this ignition lag time increases. If the 2 lean, the ignition lag time increases. Because of the oxygen molecules cannot find the fuel molecules. The fuel molecules. Suppose in case of 2 lean, the more amount of oxygen air molecules, so it is not sufficient for the fuel molecules. But in case of the rich mixture, the fuel, right, more fuel available, less amount of oxygen molecules, right? That is the reason maybe the ignition lag increases again. And this electrode gap also one of the important factor for the ignition lag. So if the gap is too small, quenching of the flame, nucleus may be occur. See, this is the electrode gap, right? And also the compression ratio affects the 5, 6, 8, 10. So the compression ratio is at 10. What is the ignition electrode gap? See, it is a very minimum electrode gap. The compression ratio decreases, the electrode gap is increases. And because of the turbulence also increasing the propagation of the decreasing the ignition lag time, turbulence. There is a more turbulence, then more mixing takes place. Right? Then the ignition lag time decreases. And the propagation of the flame, right? The propagation of the flame, the velocity of the flame, right, increases, the pressure increases. Okay. This turbulent flame spreads away the spot discharge location. The turbulent flame starts, right, discharge the spot location, the heat transfer. So diffusion of burning fuel molecules from the combustion zone to the adjacent layer of the unburned cell. During the propagation of the flame, right, the diffusion of the combustion zone, burning fuel molecules in the combustion zone, right, to traverse the adjacent unburnt mixture. So the flame movement depends upon the reaction rate and the transposition rate. What is the reaction rate? What is the transposition rate? So reaction rate is the physical movement of the flame. The flame yields its way into the unburnt charge. That is the physical movement. Transposition rate, reaction rate, that is the flame heats out the unburnt charge because of the chemical combination. Right? And transposition rate, physical movement of the flame to relate to the wall cylinder. It depends upon the pressure between the burnt gases and unburnt gases. Right? So already the pressure, right, the burnt gas region, the unburnt gas region. There are two different regions inside the combustion chamber. So what is the pressure inside the burnt gas region? It's higher than the unburnt region. That's why the energy flows from higher energy to lower energy. That means the fuel, the burnt charge flows to the unburnt charge. So that the transposition rate increases. It depends upon the pressure difference between the burnt gases and unburnt gases. This is the flame propagation. So that is like you can categorize the three areas: area 1, area 2, area 3. In area 1, the low transposition rate and the low reaction rate. Because of initially the very low because of the very small quantity of fuel only burned initial state. Right? A to B. After B, almost the fuel is ready with combustion, right? Then the flame travels at a faster rate, which is the flame propagation. And high position, the mixing also increases, chemical reaction increases. At the same time, the high transposition rate, the traveling at a high speed. Right? And the C to D, finally again the flame speed get decreases because of there is no fuel available to burn. Very less quantity of fuel. At the same time, it attains in the expansion stroke also. The pressure get decreases. That's why the flame velocity get decreases. The low transmission rate and the low reaction rate. And see effect of operating variables on flame travel. See the fuel air ratio. So this is little richer than the stoichiometric ratio, around 1.2. The flame time in seconds. See the left hand diagram, left hand figure. What is the time taken to completely burn the fuel? Lesser than 0.001, maybe 0.005 seconds to take the complete burn. Maybe the slightly rich mixture. Okay. And see, there are rich mixture and lean mixture and stoichiometric mixture. In case of this rich mixture, the complete combustion, the pressure increases. Right? The flame velocity increases. So due to the flame velocity burn completely, then the pressure increases. So the stoichiometric mixture, the flame velocities get decreases. Right? Then that means the pressure increases gradually. But in case of weak mixture, due to failed combustion, it now develops the maximum pressure. That's why the pressure increases that much lower. Okay. And also, if you increasing the compression ratio, again the flame speed increases. Flame speed, right? Then the pressure also, see the pressure increases. What is the pressure? See around, see the compression ratio 6.1. The indicated mean effective pressure 10.1 bar. At what is the, it takes 0.0037 seconds because of due to higher compression ratio. Right. So what is the time duration of the flame propagation? It's a 34 Frank candle. This is the compression ratio 6.1 to 5.1. Then what about the pressure develops? 35 bar only. Again the time taken 0.045 seconds. So the duration 41 degree Frank candle. Still you reduce the pressure compression ratio, then the pressure develops 25 bar. Or the time taken 49 degree crank angle 0.005 per second. So that from this figure you can increase the compression ratio, right? You can reduce the flame propagation time and also increase the pressure and also the engine speed. If you increase the engine speed, then decreasing the flame That is the flame propagation time, right? That's why we increase the velocity of the flame. For example, the 500 standard car ideal ideal condition, the speed of 500 RPM, with around 90% of fuel, right, burned during 16.7 milliseconds. Suppose increasing the standard car maximum power 4000 RPM with 2.1 milliseconds. Suppose if you go for the Formula car 19,000 RPM, then what is the time taken for burn the fuel burn 0.4 milliseconds. So that if we increase the speed, then we can decrease the flame traveling time, so that the velocity of the flame gets increases. That's why the complete combustion, the pressure increases every time. And also engine size. Based on the engine size, we can get the that is the flame, correct flame, and engine load. If the increase in engine load, the pressure increases. Then automatically, if the pressure increases, then the velocity of flame gets increases. When the velocity of flame increases, you can get the, and also complete combustion at a higher load. Suppose in case of over combustion at the lower load is not increasing the engine load, right? The decreasing. And turbulence, already we discussed in the turbulence. If increasing the turbulence, then we can do the propagation speed increases, the velocity also increases, then the pressure increases in the cylinder. So then finally, after burning. So after burning stage, the low flame velocity, I told you, right? The flame velocity decreases because of there is no fuel available at the end. There is no further pressure rise because of it starts the expansion stroke. Expansion. That's why after burning, we go flame velocity. And abnormal combustion and normal combustion. See, abnormal combustion, normal combustion and slight knock and intense knock. See, normal combustion, the fuel burns slowly, right? The flame propagates in the correct manner, it consumes all the unburnt charge. Then it looks like this. But in case of slight knock, there is the wavy forms occurring, right, at the later on the exhaust stroke. That is the after TDC. Why? Because of the ignition, pre-ignition, right? Pre-ignition occurs at the end of the charge. So that due to this ignition, already the flame travels in one direction, the regular flame travels across the cylinder. Due to the pre-ignition, already the fuel attains the ignition temperature, then the flame starts on the side. So this flame travels in the opposite direction. Sometimes the both flame collide at a particular place. There the vibration occurs. That is a slight knock, and that is the intense knock, right? See, this is the knocking. That is a knocking, auto ignition. See this right-hand diagram. So there is the auto ignition sites, the red color, right? The auto ignition sites. The flame travels across the chamber. So the auto ignition site starts the combustion. So the flame travels in the opposite direction. So one end, both the flame hits at one end, then the vibration takes place. That is called the knocking. See this diagram. The first diagram, normal combustion, and B1 is the combustion with the detonation. So A, the flame starts to travel the point A. So slowly the flame travels across the combustion chamber. It attains B and B dash. So this after B and B dash, the shaded portion is the unbound charge. So the unbound charge, the ignition temperature, if not attain the ignition temperature of the fuel, that's why this flame consume the unbound charge and burn completely. You will get the smooth curve. But in case of the second one, same, the flame travels up to B dash. So in the B dash, after B dash, they have the two different shaded portion, right? So C dash D, it is the auto ignition part, right? So there the flame travels in the opposite direction. It meets so that the vibration takes place. Knocking combustion. Okay, up to I can just like to stop this up to this one I can show you. Spark, okay, the spark occurs Right. That time, after occurring the spark, immediately it will not combustion takes place. The next stage, combustion begins. Then in between, it is the ignition lag. So once the flame travels across the combustion chamber, slowly it ends, right? But the second figure, see the second one. So before sparking, right? Before sparking, see this is the ignition, right? Starts because of already this temperature of the spot is higher because of due to carbon deposited on the inside the combustion chamber, right? So due to this deposit of the carbon, it hits the air fuel mixture before sparking. Then automatically the flame travels in the opposite direction without executing this spark plug. Later, then the flame travels in the other direction. Both sometimes it closes. Correct. So it is the pre-ignition. Okay. The third one is the auto ignition. Even the sparking, right? The flame travels like this. Then auto ignition starts due to ignition temperature. Right? It reaches the ignition temperature. This one. And reason for detonation. Already we discussed the too much compression, over advanced sparking, right? Then too much pressure increases, overheating, low coolant supply, too hot thermostat, bad water quantity. These are the reasons for detonation. See some damage and the reasons. See, due to detonation, the piston gets damaged. So it is the carbon deposit on the top of the piston. And what are the effects of detonation? Noise at the utmost operation, mechanical damage, increase the heat transfer, pre-ignition, decrease the power output. Okay, due to this one, automatically decreases because of more vibration, you won't get the maximum power. So how to prevent this detonation or the use of the lower compression ratio? You can go for the optimum compression ratio, increasing the turbulence, you can increase the turbulence, then complete combustion, from combustion. And selecting the suitable combustion chamber, then we can provide the turbulence. And relocation of the spark plug, use of 2 or more spark plug. Idea of decreasing the detonation. Some damages you can see. The connecting rod gets thrown out, and the piston is released. So because of this is the abnormal combustion. Okay. Okay, I can discuss the open session. If you have any doubt, we can. Okay, from the Vijay Mark, then we can continue the open session.
Yes, Aswan sir, any queries we can clarify now. Otherwise, we'll start the session at the afternoon.
Yes, sir. Voice is audible, sir.
Your voice is not audible, sir. Please raise your voice.
So now,
Okay.
now it is okay, sir.
Yeah.
Sir,
Hello.
sir, can I go for the question?
Yeah, but any noise coming from your side. I
Yeah,
think
just
okay.
a minute. Now it is okay, sir?
Okay, better than earlier. Please, yeah, tell me.
Yes, sir. Sir, actually, I just observed from the last 2 or 3 slides, you said that damage to the cylinder, all those things. If you using that blended